Hello and welcome to another RLabs tutorial. In this short video, we will continue with our discussion on loops, this time focusing on while loops. While loops are fairly simple to understand. The main difference between a for loop and a while loop is that with while loops, we do not specify the number of iterations in the loop. We just want the loop to keep running while some statement is true. So we have the word while. Then we specify a logical condition inside of these round brackets using some of the conditional operators that we looked at in a previous video. And finally, we have commands inside of our curly brackets, and these commands will be executed repeatedly in order of appearance while the specified condition holds true. So flipping to RStudio, we'll start with a very simple example. First, we want to define a variable. We have to give our loop a value to start with. So in this example, we'll say x gets 1. And then we can say, while x is less than 10, we are going to first print x, and then we're going to let x get x plus 1. So we are overriding our variable x. And as you can see, we get the numbers 1 to 9 printed out. Let's take a look at what just happened. So here's the code that we typed into RStudio. And over here, we're going to keep track of what the value of x is and what the R output would be. So we know that our starting value for the loop is 1. The first thing the loop does is check whether the conditional statement holds true for the starting value. In our case, we would ask true or false, 1 is less than 10. That is a true statement, so we can move on to the next part of the loop, which says print x. And this means that we're going to get our first output, 1. Since x is equal to 1 right now. And then moving on, the next step is to override the value of x. X no longer gets 1, it gets the old value of x plus 1. So now x is equal to 2. Now that's not an output yet, we're just assigning a new value to the variable. But because our new value of x is still less than 10, our conditional statement is still true, and we can print x. And get a new value for x as well. And this continues like this until we get up to x equals 9. Now this still passes the conditional test of being less than 10. So we can print x, which is now 9, and we can redefine our variable x. So now x gets 9 plus 1, which is 10. But now when we ask true or false, x is less than 10, the answer is false. So we cannot continue with the rest of the loop, and our output goes from 1 to 9, not from 1 to 10. And that is exactly what we saw as the output in R. Now something to keep in mind is that the output may differ slightly based on where in your list of commands you specify the output. So in this first example, print x, the code that produces an output, is the first command that the loop specifies. Now what would happen if we put this command last? So the code would now look like this. Well, let's take a look in RStudio. So we'll run this code. And as you can see, we get 2 to 10 instead of 1 to 9. And that is because our code does not allow us to print the first value of x. We start with x gets 1, which satisfies the conditional test of x needing to be less than 10. And then before we produce our first output, we actually redefine x. We now set x to be the old value of x plus 1, which is 2. And then we print x. So our first x output is 2. And that continues on, and then we get to x gets 9. Our condition is still true here, so we can run through the loop. X gets x plus 1, so x gets 10, and then we print that x, so 10 is an output in this case. But then the loop ends there, because the next x value to run through the loop would be 10, which does not satisfy the conditional statement. Now what happens if we actually take print x right out of the loop? Well, since the while loop still runs but is not being told to continuously print x, when we actually do print x after running the loop, we get only the last value, or the current value of x, which we just saw is equal to 10. As with for loops, we might want to store the output values of our while loop in a vector so that we can use the numbers, and there is a very simple way to do this. So first, we want to prepare a completely empty vector. We don't even specify how many elements we want to be in that vector, because often with while loops, we don't know how many values we will end up with. So if we call up that vector, we can see that there is absolutely nothing there. And then we define our variable as usual, so x gets 1. And then we start writing our while loop. So while x is less than 10, open curly brackets, and then we have this command here, which allows for the storage vector to be overridden. So the new storage vector gets concatenate the old storage vector and x. And then this second command allows x to keep increasing, and then we close our curly brackets. And then we have our storage vector, which we can actually manipulate and work with. So let's just run through this code quickly. So here's our code, and we'll keep track of what is in our storage vector and what the value of x is. Now we already know that the storage vector starts out being empty and that the x value starts out being 1. And since x is less than 10, we can run through this loop. First, our storage vector becomes a combination of the original storage vector and the x value. And since there was nothing in the vector beforehand, combining the storage vector and x yields a vector containing the number 1. And then the next step is to redefine the variable x. The new value of x is the old value, which was 1, plus 1, which is 2. And then we start over again. It is true that the new value of x, 2, is less than 10. So then the new storage vector is going to be a combination of the old storage vector, which contains only the number 1 so far, and the value x, which is 2. So the new vector contains the numbers 1 and 2. And x now becomes the old value of x plus 1, which is 3. And then the loop starts over again and continues until the value of x is greater than or equal to 10. And then the final vector contains the numbers 1 to 9. Now this storage command is the command that produces the output in this case, instead of the print command from the previous examples. But as with the print command, if we moved this storage command to the end of the list of commands, we would get a vector containing the numbers 2 to 10 instead of 1 to 9. Also, just a quick side note, in our video on for loops, we looked at a couple of ways to store the outputs, and using this concatenate storage x method is in fact another way to do that as well. As was the case with for loops, it is possible to nest while loops as well. Here's a quick example. So we start by defining the variable I. We'll stick with I gets 1, and then we'll start our first loop. While I is less than or equal to 2, open our curly brackets, and then we immediately start our second loop. Again, we need to first define a variable. This time we'll use j gets 1. And our second loop says, while j is less than or equal to 2, print concatenate ij. Then we have a command to allow j to keep increasing. We finish off this nested while loop with a curly bracket, and then we continue on with the first while loop with this command to allow I to keep increasing and a final curly bracket. And we get 1, 1, 1, 2, 2, 1, 2, 2. Here are the I values, and here are the j values. Now this output clearly shows how R deals with nested loops. We start with the first value of the first loop and execute the second while loop entirely for that first value before moving on to the next value of the first while loop. In a similar way, we can also nest a for loop inside a while loop and vice versa. Now we do have to be careful when using while loops because it is possible to create an infinite loop, which basically cannot ever stop. And this can stall the program and can be very annoying. So I'll just show you what an infinite loop might look like. So we'll say x gets 1, and while x is less than 2, print x. And we'll close our curly brackets. And since we did not write a command to increment x, x will always be 1, which will always be less than 2. So our code will print 1 over and over and over again, as you can see here. So since this isn't ever going to stop on its own unless the system eventually crashes, I am just going to hit the stop button here. But you can see how many 1s were printed just in that short amount of time. I can't even scroll up high enough to see our code anymore. Now you might not understand right now why you would ever want to use a while loop, but if you continue watching our videos, you will find some nice applications of while loops in the simulation modeling module. So stay tuned. Thanks for listening to this RLabs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.